Yeah, good morning students. Today I am going to explain about analogy between vectors and signals in signals and systems subject. Okay, now what is the use of this analogy between vectors and signals? Normally we don't have direct concepts for signals whenever if you want to find out the similarity between two signals. So that's why we are going to take the vectors concepts and we are giving those concepts to signals. So first let us see what are the concepts of vectors first. So for this purpose what I am going to do is I am going to take two vectors, vector v1 and vector v2. Now let us see. Now I am going to take vector v1 one vector and another vector making certain angle, that is what we will call it as theta. So this is what vector v1 I am going to assume it, and another vector v2. Okay. Now if I want to find out the similarity between these two vectors v1 and v2, so what I am going to do is I am going to draw a perpendicular line from this tip of v1, a perpendicular line from tip of v1 onto perpendicular line from tip of v1 onto v2. So this point I am going to call it as a component. This point I am going to call it as a component. Okay, component C, it is represented with C. Okay, on vector component of vector v1 on vector v2, then it is called C12. Okay, C12 is the similarity component, where C12 is nothing but that similarity component. C12 is nothing but similarity component, right? Like this you may have get a doubt that, sir, why should I draw only a perpendicular line? Why not making certain angle? Yes, it is also possible. Yes, it is also possible. Okay, we have different alternate ways. Before going to that different alternate ways, so what I am going to do is, first I am going to equate these two. V1 is approximately equal to C12 V2. Okay, whereas I am going to consider this vector as V. Okay, therefore V1 is exactly equal to C12 V2 plus VE, C12 V2 plus VE. Okay, this is the equation. Okay, whereas VE is the error vector, C12 is the component, okay, of vector V1 onto V2. Okay, this is the equation for V1. So now let us see the alternate ways of another, taking this. Yeah. Now let us see the next cases. Let us see the next cases with a different color I am going to indicate here. Let us take this one. This is, let us assume this is V2 and making certain angle with vector V1. This is V1. Okay, here instead of taking a perpendicular line, I am going to take a one more angle, and also one more example also let us take. Okay, this is vector V2 or vector V1. Okay. Okay, this is also making certain angle, this is also theta, this is also theta, and here in a different direction. Yes, this is also C12 and this is also C12. Okay, here I am going to call this vector as VE1, error as VE1, and this is as VE2. Therefore V1 is approximately equal to C1 to V2, whereas V1 is exactly equal to C1 to V2 plus VE1. This is one way of representation, and this is another way of representation. Again, V1 is equal to C1 to V2 plus VE2. This is another way of representation. Yes. So, if you observe, in n different ways we can find out the similarity between two vectors here. Okay. So, what is the generalized form is this one, whereas generalized method we are going to use is whenever you want to find out the similarity between two vectors, very simple, what we are going to do is we are going to draw a perpendicular line from the tip of V1 onto V2. Okay. Therefore, V1 is approximately equal to C1 to V2 and V1 is equal to C1 to V2 plus VE, guys. So, you have to be very thorough with this concept, because this is the very, very important topic in the entire first chapter. Okay. So, next, coming to this, V1 equal to C1 to V2 plus VE. Okay. Now, if you observe this triangle, it is a right angle triangle. Okay. Therefore, if it is a right angle triangle, cos theta equal to, according to the trigonometry, we have the equation cos theta equal to adjacent by hypotenuse. Okay. Cos theta equal to adjacent by hypotenuse. So, what we have to do is here, now what we are doing, we are taking the generalized equation V1 equal to C1 to V2 plus VE. So, according to the right angle triangle, okay, cos theta equal to adjacent by hypotenuse. What is the adjacent here? We have C1 to V2. Okay, therefore, cos theta equal to C1 to V2, hypotenuse is V1. Therefore, cos theta equal to C1 to V2 by V1. Therefore, now V1 cos theta equal to C1 to V2. Okay, where now according to the dot product of vectors, we have a formula V1 dot V2 equal to V1 V2 cos theta. Therefore, V1 cos theta equal to what is the equation we have? Therefore, V1 V2 by V2, V1 V2 by V2. Now, this is the equation A, this is equation B. If you compare these two, we have the common thing is here V1 cos theta and V1 cos theta. If you equate these two things, therefore, then C1 to V2 equal to V1 dot V2 by V2. So, this is what we have to find out. We have one more step. The objective of this finding out C12, objective is to find out the C12 value. Therefore, C12 equal to V1 dot V2 by C12 equal to V1 dot C12 equal to V1 dot V2 by V2 into V2. Therefore, C12 equal to V1 dot V2 by V2 square. So, this is what we got for vectors whenever we take two vectors. Now, let us see and let us apply all these concepts in signals. So, for this purpose, what we are going to do is, now let us see the condition for orthogonality before going to signals concept. Okay, let us see the condition for orthogonality. Okay, what is the condition for orthogonality? Whenever there are two perpendicular vectors, this is one vector V1, let us assume, another vector V2, another vector V2, or we can draw, let us draw first this one and next that one. Okay, yeah, instead of going that way, okay, then we will get a better signal. Okay, yes, whenever we got two perpendicular signals, let us take vector V1 and V2. Okay, these two are perpendicular. Whenever these two perpendicular vectors are there, if you want to find out the similarity component, if you want to draw a similarity component, is it possible? What is the method we use to draw the similarity component? We are going to draw from the tip of V2 on V1. So, therefore, we are going to, if you draw like this, so it will reach the origin. Therefore, whenever two mutual perpendicular vectors are there, whenever mutual perpendicular vectors are there, what about C12? C12 is equal to 0. This is the condition for orthogonality. This is the condition for orthogonality. Okay. Now, let us see the concept of signals. Okay. Let us go to signals concept. Now, let us see the signals. Okay. Let us consider two signals. Two signals are f1 of t and another signal is f2 of t. These are the two signals. Okay. Now, if I want to find out the similarity between these two signals, now I don't have direct formulas for signals. Just what I am going to do is, whatever the formulas I used in vectors, directly placing those concepts in signals. So, whenever two vectors are there, v1 and v2, okay, what is v1 is approximately equal to c1 to v2. Like that, f1 of t is approximately equal to c1 to f2 of t. Okay, whereas v1 is exactly equal to what? In the last slide we discussed about, it is c1 to v2 plus v. Like that, therefore, f1 of t is exactly equal to c1 to f2 of t plus fe of t. So, here the objective is to find out minimize the error, okay, in order to find out the similarity. Okay, whenever you are comparing two signals, if you are going to comparing two magnitude of the signals, so what we have to do? We have to minimize the error. We have to minimize the gap between these two. Then you will get the proper similarity. Okay, therefore easily you can find out the similarity. Therefore, what we have to do is we have to minimize the error. So, first we have to find out what is fe of t. Therefore, fe of t equal to f1 of t minus c1 to f2 of t. fe of t is f1 of t minus c1 to fe of t. Okay, guys. Now, what I am going to do is, in order to minimize fe of t, we are going to use mean square error formulae. Okay, what is the use of mean square error? Okay, what is mean square error? First, let us discuss what is mean square error. Okay, first, in order to minimize error, we have two methods. The first method is called as mean error. First method is mean error. The second method is mean square error, and most effective method to find out the error. Okay, to minimize the error, mean square error. Okay, why we are not going to use mean error? Okay, let us take one. I am going to approximate my signal, a sinusoidal signal, with another signal called square wave. Let us take square wave. Okay, yeah, I am not able to draw exactly. Okay, let us see like this. Okay, now the square wave is a known amplitude, that is 1. Let us assume this is, after finding out, I got some 1.2. The amplitude of sinusoidal signal is 1.2. Okay, here it is minus 1 and here it is minus 1.2 is the amplitude of the sinusoidal signal. So, if you find out the error, if you want to find out if you are finding out the similarity between these two signals, okay, what is the error you got? Here it is 0.2, here it is minus 0.2, here it is again 0.2, here again it is minus 0.2. If you, in this mean square error, if you apply the formulae epsilon equal to 1 by t2 minus t1 integral over t1 to t2 fe of t dt. For suppose it's an all addition, right? So, what I am going to do? 0.2 minus 0.2 plus 0.2 minus 0.2. So, plus 0.2 minus 0.2 plus 0.2 minus 0.2. Everything is going to get cancelled. Even though you have error, okay, you are going to get 0. So, that's why mean error is not a suitable method in order to minimize the error. So, that's why we are going for mean square error. In mean square error, what I am going to do is simply I am going to square it, okay, plus square it, plus here also square it, okay. Therefore, this will becomes 0.04 like this, 0.04 like this, all negative values becomes positive, and then the entire you will get a error value, proper error value you are going to get it. So that's why mean square error is always suggestible when compared with the mean error mechanism. So for that mean square error, we have an important formula you have to remember, guys. Epsilon equal to 1 by t2 minus t1 integral over t1 to t2 fe square of t dt. This is the formula for mean square error. This is the formula for mean square error. Now let us see. Okay. Now what is fe of t? We know that we are already solved it. Fe of t equal to f1 of t minus c1 to f2 of c1 to f2 of t. Now substituting this fe of t value in this equation 2. Okay. Now after substituting, just f1 of t minus c1 to f2 of t whole square dt, a minus b whole square formula, a square plus b square minus 2ab. Now I am elaborating a minus b whole square. Now epsilon equal to 1 by t2 minus t1, t1 to integral over t1 to t2, f1 square of t plus c12 square, c12 square into f2 square of t minus 2 f1 of t, c1 to f2 of t dt. So I am applying simply this a minus b whole square formula. Now what I have to do here, it is a very important topic now, interesting thing you have to observe here, guys. Yes. Now what I have to do is I want to minimize the error. And my objective is to find out the C12 value. I have to minimize the error with respect to C12. So therefore, now I am applying differentiation. Whenever if you want to minimize, then obviously you have to go for differentiation. Therefore, dou epsilon by dou C12 equal to 0, or d epsilon by d C12, it's a partial differentiation. Okay, differentiation you can apply here. Okay. Now 1 by t2 minus t1 integral over t1 to t2. Okay. Now d by dx of a constant, it is 0. So therefore here I am differentiating with respect to C12, but here I don't have any C12 variable. So obviously this will become a constant. Therefore d by dx of a constant is 0, d by dx of x square is 2x, 2 into c1 to f2 square of t minus 2 into d by dx of x is 1. Therefore 2 into 1 is 2, therefore 2 into f1 of t into f2 of t dt equal to 0. Now what I am going to do is, okay, so just integral over t1 to t2, no need of having 0 here, the same step I am repeating here. Now I am taking this particular variable this side, therefore 2 into c1 to integral over t1 to t2 f2 square of t dt, that is equal to 2 into integral over t1 to t2 f1 of t into f2 of t dt. 2 will get cancelled. Then what is my objective? I want to find out C12. Therefore C12 equal to integral over t1 to t2 f1 of t into f2 of t dt by integral over t1 to t2 f2 square of t dt. This is what C12. Okay, guys, if you observe, what you have to observe here, it's very important, guys. Okay, for two vectors, whenever you took two vectors, whereas C12 equal to V1 into V2 by V2 square. If you observe these two, both are same or not? Yes, here it is, these are vectors, here these are signals, that's it. F1 of t is the representation of function represent or signal representation, F1 of t into F2 of t by F2 square of t, whereas C12 equal to V1 into V2 by V2 square. So this is, we have all the concepts of vectors and we are applying all these concepts of vectors to signals. That's it. We don't have direct formulas for signals. Simply we have to remember here the mean square error formula. Okay, whereas epsilon equal to 1 by t2 minus t1 integral over t1 to t2 fe square of t dt. Okay, guys. Okay, so thank you so much. Let us see the next concept in the next class. Okay.